Hello, this is how to create Flatpak packages from KDE software. I searched on Google for KDE Wiki Flatpak. I wanted this result, guidelines and how-tos Flatpak. This sends you to Flatpak development information, which is a tutorial from develop.kde.org/doc/packaging/Flatpak. We're going to start with our first Flatpak. So Flatpak is a packaging technology similar to Snap, to AppImage. There's a repository that's well known, which is called flathub. There are other repositories such as the KDE Nightly. There are runtimes, the free desktop one, the GNOME one, the KDE one. The KDE runtime for Flatpak contains Qt libraries and many of the KDE frameworks. Okay, in this example that we're going to follow, we want to create a Flatpak package from the Kate text editor, and the KDE Flatpak runtime contains all of the needed dependencies, all of the needed Qt frameworks, all of the needed KDE frameworks. So we could just git clone the KDE Kate Git repository, build straight from Git master, and not need any other dependencies than our KDE platform, the current version, which is 6.8, and the associated org.kde.sdk. In order to build Kate correctly, you would need more dependencies, but just using our KDE platform, you can build a very functional Kate Flatpak. Okay, so we will need a manifest, a single plain text file. Similar to the way you would work in Docker, you have just one file, a Docker file or a container file. When creating a Flatpak, you have just one file with extension either JSON or YAML. And then there's a tool that you give this plain text file as a parameter to that tool. This is the minimal example file that is needed in order to create a Flatpak package of Kate, built straight from Git master branch. So let's follow the tutorial. This is how the YAML looks like. This is how the JSON looks like. They're identical. Even more so, this YAML file is part of the tutorial, and the JSON representation is just created when the website is generated. So in the source code of the website, only the YAML content exists, and the JSON file is generated on the fly. This is how identical these two files are, except the syntax. Let's use the JSON format, and we'll need a name for this file. We can see in the example below that the name that we want is this one. For Flatpak, the name of the file is not that well preferred, as for instance in the Docker world, where you either have Docker file or container file. In here, the name of the file needed to build the Flatpak will be different according to the culture of different projects that build Flatpaks. We have copied the name of the file. Let's get a directory and a console in there, a terminal. Let's create the file. Copy the content. If we want other modules than Kate, so if you want a dependency that's not part of our KDE platform, not part of this Git repository for Kate, then we need to be careful to add those modules before this module. So modules is an array, a list, and this is the object of one module, which is the one for Kate. So we need another module object before the module object for Kate. Let's first see if we can build just like this without any additional dependencies except the org KDE platform and SDK. So we want to add flathub, which is a remote. When we install remotes or packages for Flatpak, we could either install them for the entire machine, which might require sudo permissions, or we can install these per user for just the current user. The only difference is that you will use --user as one of the command line parameters. Let's see what this command does. So it says that per user, not per machine. If not exists, so if we have already added this Flatpak remote, nothing will happen. But if the remote was not added, so if not exists, then a remote named flathub, which has this actual URL, will be added. So let's do it. Says flatpak command not found. So before building Flatpaks, we will need at least binaries for Flatpak and Flatpak-builder. The simplest way to get these is from your Linux operating system, if your Linux operating system is new enough. So in my case, it's the latest version of Kubuntu, Kubuntu 25.04. I will have new enough versions of these packages. Flatpak and Flatpak-builder. This is exactly the name of both the executable and the deb binary package. So the deb binary package is named Flatpak and the executable is named flatpak/usr/bin/flatpak. And the deb package is named flatpak-builder and the executable is /usr/bin/flatpak-builder. There are some dependencies for these packages, technologies which are related to portals, to free desktop, to snaps, to security sandboxing. So AppStream is about a XML file that describes software, such as the software name, the software icon, the software description, the software screenshots, etc. GTK introspection. This is PolicyKit. This is OS3, which is a technology that's similar to Git, but it's created for also for binary files, also for symlinks, also for bootable operating systems. Whereas Git is more well suited for plain text files, or files which are easy to diff. More upstream, more OS3. Okay, the packages have been installed. Now we can try to run again the flatpak remote add command. I'm pressing the up arrow key twice. It complains that the flatpak executable exists, so we've just installed it using apt install. We have added a remote, but two of the directories which should be part of the environment variable xdg data dirs are not part of the environment variable yet. So it suggests that I log out of KDE Plasma session and log back in. Let me do that. So I have logged out of KDE Plasma session. I went back to SDDM, the desktop manager, and then logged back in. I'm going to run the same command again and see if this time it complains. So this time it did not complain that the environment variable did not have the correct value. Next up, I'm just going to try to build. Let's look at the command line. So the command line says flatpak-builder build user install deps from flathub force clean ccache install. So it's going to use the per user flatpak remote and installation. It's going to install the generated build package, flatpak package. It's going to do a build as clean as possible. Building or installing might require additional dependencies, except from what we already have installed, which is nothing. We did not install any flatpak yet. Let's see that. Okay, so building and installing will require the org KDE platform, or .kde.platform will be required certainly for running the Kate flatpak, and then org.kde.sdk will certainly be required in order to be able to build the Kate Git repository. So it will have in there things like a C++ compiler, a linker, include files, etc. So it says that org.kde.sdk was not installed previously. It's installing it for the correct CPU architecture, x86_64. The version of the SDK that's going to be installed, we have specified in the org.kde.kate.json file, which is 6.8. Then it installs the dependencies of org.kde.sdk, which is org.free desktop.platform, which is the one of the three major flatpak platforms. So there's free desktop, GNOME, and KDE. There's additional flatpak packages, extensions, extra data, etc., which will probably get installed when you install org.kde.platform or org.freedesktop.platform. Such one of these extensions is the OpenGL acceleration. There's another one for H.264 video decoder from Cisco. The KDE community prefers that KDE apps, when running, use the default KDE themes, the default KDE icon set, which is called Breeze, the default KDE Qt widgets themes, Qt QML themes, etc. That's why these packages being installed, org.gtk.gtk3 theme Breeze, such that GTK3 applications will use a GTK3 theme that's as similar to the default KDE theme Breeze as possible. Okay, so in here many Flatpak packages have been installed. I'm going to guess that the size of these packages is more than 500 megabyte combined. Those packages have been installed. And then we're at the step this one, patching the Git repository for the first module. It has created a Git repository, so that's git init dot. Let's see where. The hidden directory .flatpak-builder, git, full path of the URL of the Git repository for the first module. And this is where it, it goes git init dot instead of going git clone. I'm not sure what that is about. It's doing fetch on this. And then after the source code of the Kate Git repository is available locally, it's going to follow the instructions, which is this line, line 12, that says build system is CMake Ninja. So CMake and Ninja are installed as part of the org.kde.sdk or of part of one of its dependencies, such as maybe the SDK for org.freedesktop. So this requires Kate. This requires CMake, which is a build system, requires Ninja, which is something similar to GNU Make, requires the C++ GNU toolchain, and the include and libraries from many Qt libraries and KDE frameworks. After that, it runs the configure step, which is CMake configure, and then it runs the build step, which is CMake build, and then the build binaries will get installed into a special place, which is /app. it's not being installed in /app on my host computer because I probably don't have access there. We're not using sudo, we're just running all of the commands as my Linux user account. Hopefully we're not touching anything outside of my home directory. This installing part is the Ninja install command line, which is probably wrapped inside a cmake install command line. Okay, then it's working with debug symbols, compressing, stripping, etc. Generates files with extension .debug. Okay. It puts additional files such that the Flatpak will be, after the Flatpak of Kate is being installed, the application is going to be present in my start menu. So that's meta info, app data, desktop, and icons. iColor, various sizes, apps, Kate.png. In this Git repository, in this case, invent.kate.org/utility/Kate, leave two different graphical user interface applications. The one that we would expect, which is Kate, and then there's a second one, which is called kwrite, which is a stripped down version of Kate. Kate has plugins, and kwrite has way less plugins than Kate, but they use the same exterior shell with different .desktop files with different icons. Okay, then there's a Flatpak repository, and by the fact that we did ---- install, the executable flatpak-builder is actually going to install the built Flatpak package. It's going to install it per my user. There's additional flatpaks being built except the org.kd.kate. There's a flatpak for translations, org.kd.kate.local. There's another flatpak package for the debug symbols. We saw that debug symbols have been stripped, put to different files, compressed, etc. And then this binary flatpak package has been created, which is org.kd.kate.debug. Okay, now the application Kate has been built correctly as a flatpak, and the flatpak has been installed. That means that the Kate application should be available in my start menu and in other places. So let's see if that's the case. Development category, and it's here. It says KDE Nightly, which we specified on line 3 of org.kd.kate.json file. We say that the name of the desktop file, whatever the title that's being used for the application that's being extracted from the .desktop file, should not be the default one, which in this case is Kate with an uppercase K, but should be the default one, plus a space, plus within parentheses, nightly with an uppercase N. So this is exactly what we expected. Kate space, round parentheses, nightly, and then closing parentheses. The rest of the values inside the desktop file should be the ones which are specified in the Git repository. Let's see if the application starts. First, we have two Kates installed, one from my Linux operating system from deb packages, which is this one, Kate, and the second one we've installed from flatpaks, KDE Nightly. Unfortunately, there's a bit of interaction between these two, in the sense that the Kate application tries to be single session. So if it finds the Kate application, the Kate process already running, it's going to probably bring that application into foreground and close the current application. So single instance support. That's why I have closed the currently running Kate process. Okay, we know that this is the Flatpak version of Kate, not the version of Kate that's installed from my Linux operating system, because immediately we can see that the tool window for terminal cannot be displayed correctly because we did not install console inside the Flatpak instance of Kate. So the Kate process runs sandboxed. The Kate process thinks that its full path is /up/bin/Kate, which is not the case. The process is sandboxed, a bit protected from the exterior world, but then inside of the running sandbox should be more than just the Kate executable and its dependency, libraries, icons, etc. There should also be the executable for Kate, and then there should also be the Kate part, which is a library that allows the process console to have its graphical user interface not displayed in its own main window, but inside the window of another process, the process kit. But many other features of Kate should work correctly. Let's open the current directory. Yeah, it's Kate. Let's see if in help about the application Kate knows that it's running inside Flatpak, which in my opinion is important. So when you're running the help about menu item for all of the applications, that menu item should say we're running inside of a Flatpak. We're running inside of a snap. This is part of an app image. Because when you're reporting issues to the KDE bug tracker, you need to specify this. It's not enough to say Kate crashes. You need to say Kate version this on Flatpak version that, using these platforms with console not installed, is crashing like this. So it's very important to know exactly the version of Kate that has issues and exactly where does this Kate run. So I don't see anywhere the fact that it's running inside of a Flatpak, which is a missing feature. So either in the version or in components in here, it should say that this very important information that Kate is running as a Flatpak, not as a snap, for instance. Probably from the stack traces, you will be able to determine if the application is running from Flatpak. If you have access to the full path of the running executable, you will also know if it's running as part of Flatpak. Let's see how that works. So we want ps aux and grep Kate. So you can immediately see that we have BWrap, which is bubble wrap, which is a sandboxing technology that's actually running. So after minus minus come parameters which are not for BWrap, but for the actual command that BWrap wraps. This is a convention. Minus minus means other parameters which are to be copied verbatim and sent to something, which in this case is to the second process, which is Kate. Okay, so the fact that we know that Kate is wrapped inside bubble BWrap, that the parent process of Kate is BWrap, tells us most certainly that this is a Flatpak application running. Let's look at PS3 and see Kate. I don't know where it is. It says BWrap, Kate, and then 32 more Kates. Which is this thing. Then Kate also has support for single instance process. Let's see how that works. So Kate is already running. If we try to run Kate again, it runs Kate again. Okay. So this is probably a missing feature. Anyhow, the single session support uses dbus, the Linux technology, IPC inter-process communication technology, where the first instance of Kate will get hold of a dbus path or object, and then the second time you start Kate, the new process will look, see that the dbus object is held, and not start the second instance, instead make the first instance foregrounded or something. Okay, but the rest of the application again works perfectly in the sense that the application launches, which means there's no SO file which is missing. There are no missing dependencies. Then it uses the correct Qt widgets themes, which means that the Qt widget theme KDE Breezelight has been installed. There's some additional Qt widgets themes which come from org.kde.platform, which is Windows and Fusion, which these two are part of the Qt framework, whereas Breeze is part of the KDE frameworks. Then there are the correct themes for colors, or color schemes. the Breeze ones. Even this control, graphical user interface control, is not part of Kate, it's part of a KDE framework. What probably doesn't work correctly? Let's see if the product manual works. And it does. The way help handbook is implemented in KDE applications is that sometimes the dedicated application for info center is being shown. When that's not easily possible, as in this case, because maybe the K-Info Center is not, K-Help Center is not installed at all, the executable, then a web browser is started with the latest product manual URL loaded. Okay, let's look at the list of list of loaded files. So that's lsof, grep kate. Let's put this thing to a plain text file. And we'll open that with Kate. Let's see which Kate. So this is the Kate from the operating system. I'm not exactly sure how you start Kate from the command line. Let's see files that are loaded inside of this process. This stat operation not permitted. It's probably files that exist inside the sandbox do not exist on the host computer. /app/bin/kate. I'm going to guess that does not exist on the hardware computer, on the host operating system. There's no such directory /app. It's a totally different universe inside of the Flatpak container or sandbox. Totally different paths exist inside the container, totally different paths exist on my host computer, host operating system. The step cmake install was towards /app. So in /app you will have the build artifacts and other files which come from the Kate Git repository. Most of the other files will come from /usr, which is actually from org.freedesktop.platform, org.freedesktop.sdk, not the SDK, org.kd.platform. Some of the files do come from the host operating system. And that's the directory /run/host. So files that are no arch, files that are not binary, files that are not specific to my CPU architectures, files that are not specific to the Qt version that's available inside the Flatpak instance, are taken from my host operating system. So that's /usr/share/fonts, which is surfaced inside the Flatpak instance as /run/host/fonts. There's also the fonts cache. This way the fonts are shared between all of the different flatpaks. All of the different flatpaks will see the same fonts, and the fonts are actually the fonts of the host operating system. And the same thing with the fonts cache. There's no need to create different font config, fonts cache for the different flatpaks that you're running. If you're running 10 different flatpak packages, at the same time, you don't want 10 different font cache, font config, font caches. /app/bin/kate. Let's see what's inside /app. How do we do that? With a space at the start. There's Kate text editor, which is a KDE framework. Kate private, Kate the executable, and the Kate plugins. Well, these are the Kate plugins. So a Kate plugin for file tree, tab switcher, language server, protocol client, project plugin, external tools plugin, search plugin, etc. Console plugin. So the console plugin does exist, but the console executable does not exist. Okay. Then some things are surfaced from the that environment variable xdg data dir. That's my home directory /var/up, and then the ID of the flatpak, so org.kd.kate. There's OpenGL shaders cached in there, for instance. More font config caches. Okay, so similar to Docker, you have two different worlds totally separated. What's inside the Flatpak container, the Flatpak instance, and what's on your host machine. Totally different files, .so files, everything's different there. Two different Linux installations. The host operating system and the almost complete Linux installation that's inside the Flatpak instance. Okay. We can see that console is missing, and the tutorial then tries to add the console module to the .json file. So again, before the existing module, you should add a module for the KDE Git repository of console. Let's see if that works. Might work, it might not. Let's see. Where are we? This is the Kate from the operating system. I have started it from the terminal. Again, I do not know how to start a Flatpak application from the terminal. there's two totally different applications, /usr/bin/kate, which is installed from Kubuntu 2504 binary dip packages. And then there's /up/bin/kate, that's from Flatpak, and that's from my home directory. There's flatpaks installed in my home directory. So this part needs to be included before the kate module. So something like this. Modules is a JSON array, starts from here, ends here. And then there's one module, then there's a comma, and then there's the second module. The two modules are almost identical. The same build system Kate Ninja, the CMake Ninja, the same sources, type git, URL. The URL is extremely similar. What's different, it's the last part in the git URL and the name for the module. Console versus kate. At this point, we should build again. Okay, let's see what it did. Nothing to install. Everything is up to date. It tried to update the packages that are the Flatpak packages that are mentioned in the .json file. Nothing to update. It says nothing to do after updating. And then it started git cloning and building. So it's fetching from git remote master branch. The git repository was already there. And then it runs CMake configure step, which finds different things that are needed for building, such as the GNU GCC C compiler, the GNU G++, C++ compiler, etc. Finds libraries such as X libraries, get text from GNU, but also Qt libraries and KDE frameworks. Many KDE frameworks, which are found inside the .sdk flatpaks. Including OpenGL, which we saw it's part of an extension of org.freedesktop. Okay, but let's see which module does it actually build. Kate or console. So it's building console because it's first in order in the .json file. So it looks at the modules, finds the first one for console, builds it as specified using CMake and Ninja. Once that's done, it's going to go to the second module, build that correctly using CMake Ninja, and then after it, so it runs CMake configure for console, it runs CMake build for console, and then it runs CMake install for console. And then the 3 steps also for Kate: CMake configure, build, and install. /run/build/console. So we're inside a parallel environment, inside of a container, inside of an instance when we're building the Flatpak. Something similar to a chroot, etc. Because I'm going to guess that this directory does not exist on the host machine. But we can prove that. No, this directory does not exist. And that's the way it should be. If all of the files that take part in building Flatpak software come from outside of my operating system, from Flatpak runtimes and frameworks that are managed by, in this case, by flathub, why would the actual build process take part outside of a something similar to a Flatpak instance? So, because all of those files will need to be surfaced during the build. All of the files that come from flathub will need to be present when running cmake configure, cmake build, cmake install. And also, building is going to be way cleaner if you have a mathematical guarantee that when you build flatpaks, the interior of the building process can't really see /usr from the host operating system. Okay, and now we're inside Kate. We're building the second flatpak module specified in the .json file. We're half past, so 400 C++ translation units out of 611 for building Kate. It has run the install step. Now it's running the creating the debug flatpak package step. Stripping, which means taking out the debug symbols out of existing .elf files. So that means .so files, which are shared libraries, or executables, such as the Kate executable. There's .debug files being generated, and then those are packaged inside a org.kd.kate.debug with an uppercase D flatpak package. This thing. So it says that it has also installed the newly generated org.kd.kate flatpak. And now let's see if running works. Because I don't know how to run it from the command line, I'm going to start it from the start menu, development, KDE Nightly. And the application fails to start for reasons unknown, which I have no clue how to debug. So if I build without the console module, every Kate Flatpak package can be installed correctly and does run correctly. If I also add the module for console, the Kate Flatpak package gets built correctly, installed correctly, but refuses to run. And I do not know how to debug this issue. It's not a crash, it's a normal course of action. Kate starts, and then the source code inside Kate decides that it should stop, and it stops cleanly. Running with GDB doesn't show anything interesting. But we could actually try to investigate this thing. On Google, I have searched Flatpak how to debug. I got to this debugging page. So there's confusingly two different pages, one from read the docs and the other one from docs.flatpak.org. So let's see what it says. If you want to run GDB, you will need debug symbols available inside the Flatpak instance. Let's see how that works. So we want this thing org.kd.kate debug, which is a flatpak which is available in the local repo, not in flathub, to be installed, which I don't know how to do. There's a Kate origin flatpak repo available on my machine. And then the second repo that we're using is flathub. Everything comes from flathub except Kate. But again, we need to install this thing. I have searched flatpak how to install from remote. Got to the first result using flatpak. And this says that there's an executable named flatpak that's available. In my case, I have installed it from Ubuntu 25 for binary packages. It's available as /usr/bin/flatpak on my host operating system. There's command lines to install and uninstall flatpak install, flatpak uninstall. You could use the three-part identifier, reverse DNS notation. So in my case, org.kd.kate. And if you don't specify this full path, you can just say Kate and it will identify, hopefully it will identify that you actually want org.kd.kate when you just say Kate. But in order to make extra sure, if possible, you should provide the full three-part identifier. Then the identifier can get way more complicated once you specify the CPU architecture, the branch of the flatpak remote. You can install system-wide. If you don't specify the -- user parameter, you can install per user if you specify the -- user command line parameter. There are remotes. 2, Kate -origin installed per user, and it's only available on my system. Flathub, which is available at flathub.org and was installed per user, is my flatpak user installation knows about it. I did this step, flatpak remote add -- user in my case, which I want to install per user, -- if not exists, flathub, and then the full URL for the flatpak remote. You could remove one of the remotes if you want. You can search packages. Let's see how that works. And we want this guy. Should find it in 2 places. In flathub and in Kate -origin. Says no match is found. Include debug. Maybe that's the way to go. Include debug. Okay, and now when we install packages, if the flatpak package that you want to install, specified in this case by the 3 strings identifier, if it's available in just one remote, you don't need to specify the name of the remote. But in my case, it's available in 2 remotes, so I'll always need to specify Kate -origin if I want to install it. It's already installed. So let's prepare a command line. Oh, no Kate anymore. That's not great. I have installed from binary packages sudo apt install kwrite, which is the other graphical user interface executable that comes from the Kate Git repository. And I'm running it. No welcome screen. Control V. Okay, and I want to to have these two files, two command lines combined. So I want flatpak install ---- user, include SDK, include debug. I want Kate origin. How do I do that? Control V. And then the flatpak ID, that's org.kd.gate with the lowercase. Let's see if that works. Flatpak install per user, include SDK, include debug kit, origin, org.kd.gate. Go. Let's see what it does. So it says that if you want to install the debug symbols for org.kd.gate from your Flatpak remote kate-origin, that will also need the rest of the debug symbols. So debug symbols for KDE frameworks, debug symbols for ICU, the GCC libraries, the either .so files for image formats, for audio video codecs, etc. Okay. It's great that this feature is implemented in Flatpak. Okay, so the correct .debug Flatpak packages are being installed from the correct places. So org.freedesktop.sdk debug from the flathub.org, org.kd.sdk.debug from flathub, and the correct org.kd.k.debug that we have just generated from kate-origin. Debug symbols tend to be really large. You can see the debug symbols from the KDE frameworks version 6 and from the Qt modules. So from the second line org.k.sdk.debug, that the flatpak with the debug symbols is 5.5 gigabytes. And that's probably compressed. It's just the download size, not the install size. This is a development virtual machine, so it's not a problem if I pollute this virtual machine with many developers related flatpak things. So we have installed 3.debug flatpaks, and now it says that the crash might be somewhere in the graphics stack, in the OpenGL or the software rendering, and by default the debug packages for the GL extensions are not installed by default, so we'll need to install them manually. We can see in here that the org.freedesktop.sdk.gl.debug was not installed. Org. Okay. We're not after this information. We actually want the version of the free desktop platform. So it's probably this thing, 25.0.3. Okay, so flatpak install org.freedesktop.platform.gl.gl32.debug.default. And then we need the version, so probably this one, 25.0.3. let's see the name, org.freedesktop.platform.gl .default and then .debug, probably. Nope. So these two. org.freedesktop.platform.gl.default.debug 25.0.3. Maybe it needs this thing, the branch. Okay. 24.08. Nope. Okay, so this command line is correct, but then this is not enough because we're not using just the org.freedesktop.platform. We're using also the org.kd.platform. So when we run this command line, it's not enough. It's going to show just the first platform that we depend on, which is org.kd.platform. So instead of this command line, you should run the command line flatpak list, but make sure your terminal is wide enough. And then you want to look at the column branch. And who knows, maybe we also want this one. So org.freedesktop.platform.gl.default and then 24.08 extra. I'm going to try with that also. Okay, 1 gigabyte of debug symbols to download. Okay, so the other branch is 24.08 extra. And there's an extra 1 gigabyte of debug symbols. Okay, so we're at this part. Next up, so for any of the extensions or base apps used by the app, we need to install the debug symbols because the debug symbols will only be installed for the app itself, for the flatpak of the app, and for the flatpaks of the platforms. So we'll need the different extensions to the platforms to also have debug symbols. Hopefully this is enough for now. And we want a debug shell. Let's see how this thing looks like. So I'm using the bash shell. I'm on Kubuntu 25.04. So that means that $sign and then parenthesis pwd will run the command pwd and will return the current path, this directory that ends with 1. Flatpak ID is the 3 strings identifier for our application. org.kd.kate. And that's it. A container, a bubble wrap instance was created and we're inside it. the current directory is exposed inside the running container. There's a build directory and a .json file and a hidden directory also. The directory .flatpak-builder. Okay, let's see what is sh. Is there a bash in here? Yes, there is. These are the executables that are available by default inside the running container. There's bash, there's sh, which is actually bash. /bin is a directory. Okay, so there's a file system similar to any Linux operating system file system. So there's a /bin, which is a symlink points to /usr/bin. There's a /sbin that points to /usr/sbin. /usr/sbin points to /usr/bin. /lib points to /usr/lib. /lib64 points to /usr/lib64. There's a home directory, a /run directory. This is the entire file system. In the current directory, there's a build directory. There's a hidden .flatpak-builder directory. Okay, from so parts of the home directory of the current user are being exposed inside the running container. ~.var /up/ and then the ID of the application, Flatpak ID. Some files from /dev maybe are exposed, the shared memory. The files from /etc are not exposed. /sys/devices. So extremely few directories from /dev are exposed. Okay, so a ton of things from sys/sys are probably exposed. There's /var with the cache from the Mesa shader. A bit of /proc. /run/host/share is /usr/share from the /icons from the host operating system. So just the icons. Because the icons are just PNG, just SVG files are not CPU specific, and also don't depend on a application binary interface. also exposed from the host/run/host/fonts, which is probably /usr/share/fonts. I'm not sure what /run/flatpak/doc is. Okay, /up is where we have run cmake install. There's two KDE Git repositories that have run cmake install into this directory /abb, both console and Kate. There's /up/lib/debug, including source code. Documentation for console, Kate, kwrite, Kate part. Translations. Application icons. Man pages. And then we're at /usr, which is part of the other flatpaks than the org.kd.kate flatpak. So from the many platforms, we use two platforms. From the SDKs, maybe. From the debug flatpaks, from the extensions, from the debug flatpaks of the extensions. This is C++ and C programming language include files, .h files, /usr/include. .so files, .cmake files, there's many programming languages, there's Ruby, there's Python, there's Perl, Python packages, Python 3.12, TCL, Perl 5.40.1, Ruby 3.3.0, SQLite, many libraries. Debug symbol /usr/lib/debug /usr/lib/plugins. Debug symbols for Perl, for Qt, for the KDE QML packages, for GNU awk, GStreamer, I'm not sure what DWZ is. BST. The BST files are for build stream, for the way that the org.freedesktop platform is being created and built at compile time. I'm not sure what these things are. Maybe the CPP files. So the /src directory. But it seems like in here is a very complete development environment. So maybe there's CPP files. Certainly there are .h files. There's debug symbols. The ELF files themselves. All of the components that make up the org.freedesktop.platform, so the BST directories. tar, GNU, MPFR, Xorg library, XT, curl library, WebP library, etc. Git. /usr/share/zone info with the time zones. Many translations. Okay, let's look at the /app directory. So .so files probably here. Debug symbols probably here. And source, so .cpp files probably here. Let's actually see that. Yep, cpp files, main.cpp. Yeah. The debug support is very well thought out. So this creates a sandbox for the application with a given ID. Instead of running the application, runs what we provide, which is sh, which is bash. The devel option will use the SDKs, not just the runtime. So the runtime contains just .so files, whereas the SDK will also contain additional debug and development things like /usr/bin/gdb, the GNU debugger. The GNU compiler collection, etc. So include files. Debug symbols and source files. So if you use flatpak-builder to build a flatpak, you can, for instance, not provide the -- install parameter to flatpak-builder, but instead go -- run. It will create a sandbox and will get you inside the sandbox without actually installing org.kd.kate in our case per user. Of course, you probably want -- user. Okay, GDB, the GNU debugger. Let's see first how many files we have in /up/bin. There should be 2, Kate and console. kwrite should not be part of the generated flatpak. Should be blacklisted because it's not really possible to run it. It's not exposed in the start menu. Okay. Let's see if console runs. So it complains about the fact that console, in order to start, we'd want to create some dbus connections, the interprocess communication protocol dbus, and that's not exposed through the walls of the container. Kate behaves as before, doesn't write anything to standard output or standard error. Okay, so it says GDB and then the file gdb/up/bin and then console. Okay, there's debug symbols, hopefully for absolutely everything, plus source code, so CPP files. No arguments needed. We don't want debug info D because we have already installed all of the possible debug symbols from the flathub and from the local flatpak repository that we have. So we don't want to have inside this flatpak container also files from Ubuntu. So I'm going to keep the default, which is N. Just press enter. And this way we get console. Signal abort. How do we do that? List. pthread underscore kill.c. How many threads do we have? So we're inside cute message. There's an assert. How come asserts are being executed? Is this a debug build? No, it's not. qlist.c, we saw qlist.c previously. In here says qlist.h. In Qt core, there's an assert that the list should not be empty. Console session.cpp line 569. 27 functions deep, 30 functions deep, and now we're inside the main. So in main.cpp. On line 260. Oh. In worst case scenario, if you have the need to see a backtrace or a call stack, from what I see in the Flatpak universe, there is this possibility that you see a correct, complete backtrack with all of the needed symbols, functions, source code files, source code file lines, etc. But that requires functionality that probably is not built into Flatpak, that is to install all of the debug Flatpaks. As you saw, there's a command that installs the Flatpak debug Flatpaks for your application and all of the platforms, but you also need to install the Flatpak debug packages for the extensions and extra data. For all of the things that are part of running your application, but are not platforms or the application itself. And if you want even more, you can look at the complete backtrace from all of the threads. Set logging enabled on. I'm not sure what's the name of the file where it's going to write the output. So probably in the current directory, there should be a file gdb.txt. Let's create a backtrace complete of all of the threads. I'm not sure what it's doing. Press C to continue without paging. Okay. Let's continue. Start from the beginning. No. Continue. And it has exited with sig abort. So this is a crash because of an assert. gdb.txt, the output. What text editors do we have in here? How do we get a graphical user interface text editor here? KWrite. Yep, we have KWrite. Okay. Check this out. So KWrite doesn't, by default, load many of the Kate plugins. It also doesn't load by default the problematic Kate plugin, which is the plugin for console, the console part. So that means KWrite can be started from inside the Flatpak container for Kate because it's not affected by the crash. Okay, let's see what we have here. Unfortunately, we don't have syntax highlighting because maybe that's one of the plugins that are not enabled by default in KWrite. Let's see if we can enable that. Configure KWrite plugins. Nope, no plugins. I'm not sure if KWrite supports plugins. or if it has a limited hard-coded list of plugins that it just loads and there's no graphical user interface support for users to add more Kate plugins to Keyright. Any syntax highlighting would be better than nothing. Like even the syntax highlighting for an INI file or for a C programming language. Okay, so there's many threads that don't do anything, as in any graphical user interface application. That's pthread wait, many, 30 of them. And we can see them in the minimap because they look very similar, like this one at the end, this guy. Polling, waiting, so these threads are not really doing anything. It's just a thread pool. It's waiting for the user to click somewhere. Okay, so we could just ignore all of these until thread number 1, which is the main graphical user interface thread. The threads that have a name that is different from thread pool. Let's see, so thread pooled. Console has some threads. Just waiting, probably a thread pool. There's the OpenGL software renderer LLVM pipe. That's also waiting for action. Okay, and then there's the first 3 threads that actually might do something. There's the event queue from the Xorg. XCB is the X library. There's a dbus connection. QDBus connection manager run with an event loop. Thread 1 is console. Yeah, because we're debugging the console application. Okay, the main thread number 1. So both in Linux and Windows, the first thread is very special. It's the main graphical user interface thread. In here you have the main loop. You never want this thread to not be responsive, never do, I know, sleep 1 second in here because it will mess up with the graphical user interface fluidity. You will not be able to minimize the application, to move the application, to the console blink, the mouse cursor blinking might not work, etc. So the main graphical user interface application might become unresponsive. In here, you should do as little things as possible. Once the graphical user interface main loop thread and the main loop has started. So Q application, Q GUI application, Q core application, Q event loop, and then the event loop, actually the Qt main loop actually uses a GNOME library, which is GTK, which is glib, which is the main loop from glib. So both GTK applications and Qt applications use the same type of main loop, which might make it possible to have inside the same window both GTK3 and Qt6 controls, graphical user interface controls. So gmain. There's the Qt main loop machinery with send, posted events, send event, notify, QList action, back last, and then QAssert that the list is not empty. Okay, and we're after probably the console sessions. So console doesn't have any sessions, so what? Okay, it's interesting that we can have a text editor inside the Flatpak container if run with full debug powers. What about other text editors? There's Nano. No Emacs. No VI, no Vim. I don't know how to continue. I've been programming for a long time, but I'm a Visual Studio kind of guy. I need a full integrated development environment in order to survive. I might survive with Emacs, with Kate, because Kate can open directories, and with Visual Studio Code, but that's just survival. For day-to-day work, I need a full-blown integrated development environment with a full featured debugger and all of the nice things. Okay, so maybe this is the issue. Console fails to start because it doesn't have sessions defined yet, and Kate fails to start because console fails to start. But I'm not sure how to prove that's the case. So we're at this line GDB, and then the full path to the ELF file that's an executable, so it doesn't have an extension probably. If you want to provide arguments, for instance, maybe you want to open Kate with a file as parameter. If not, once you're inside the GDB REPL, the read evaluate print loop, you can run GDB commands such as run, which we did. Okay, and it's using inferior, so there's forking going on, which means there's two Kate processes, and we're debugging the wrong one. We're debugging the parent, not the child. So we're probably not going to see anything interesting because we're in the wrong process. Program is not being run. So I have told it to run until an issue happens. No issue happened, and the process has exited normally. We could break at main, but right now it's important to not have to either tell Kate not to create a subprocess, so to not fork, or we want to follow all of the forked processes. So I'm searching on Google GDB follow fork. The GDB manual sourceware.org/GDB. And we're after set follow fork mode. The default is parent, so if our process forks and creates a child process, GDB will remain inside the parent process, will not descend into all of the children processes. Whereas child, the debugger will work inside the child process and it will not be attached to the parent process. Detach on fork. Detach on fork on means that we're either debugging the child or the parent. Or you can debug both processes. So you can go set follow fork mode child and set detach on fork off. Or maybe this is not needed if you go set the detach on fork off. One is debugged and the other is suspended. So we don't want suspended. So we're after this one. And the non-default option child. Okay. And now we can start the. So the processes have finished correctly. Process with process ID 349, 313. Because there's no assert, no C++ exception being thrown, there's no crash, no signal, no nothing. It's just the C++ source code decides that it should finish starting by stopping the process. Let's see if we can break inside main.cpp. This has created a breakpoint. Who knows where? Because there are more than one main CPP, C++ or C programming language entry points. And now we run. Let's continue. Okay, and now run. So there's many processes being started by Kate, including this get end one. It's very complicated. Once you have multiple processes, a process tree being started, using the debugger is very nebulous there. So you probably, what you really want to do is to, in this case, maybe there's a debug flag inside Kate that tells Kate, hey, don't load all of the plugins. Hey, don't create sub-processes at all. Or you're going to put a breakpoint well before the sub-processes are being started. Let's set back the follow mode. No, I don't have enough knowledge here. Kate is a really complicated application, again, because it has many plugins, it integrates with other executables, does debug, does have debug functionality, talks to other processes like getEnt and console. Very complicated. You totally should not start packaging KDE applications as flatpaks with such a complicated application. Start with something simpler, something that's single process, like, I don't know, a maybe kcalc, which is just Q widgets, doesn't use QML at all, and is single process, and is just the graphical user interface application, just one executable. From here on, your journey will be long, and what I suggest you do before actually start to package any of the KDE Git repositories as flatpaks is that you download, so git clone most of the KDE Git repositories that have applications, flatpak applications inside flathub. And build all of these on your computer. So you find one of these applications on flathub. Which one? Okay, Diamond. You make sure that it's recent enough. So 2504, 8 days ago, that's very recent. There's this tab in here which has links. In here you get to where the .json file is located, which is github.com/flathub/ the 3 strings identifiers, so org.kd.kdiamond. There's a JSON file, and this JSON file you should build using flatpak-builder on your computer. This JSON file builds flatpaks for flathub, which means in flathub the KDE project has released software. So there's release versions of the platform. org.kd.platform 6.8 has been released and is part of flathub. And libkd games is a released version. It's not taken from Git or from a Git branch or from Git master branch. It's actually taken from a source code release tarball. And the same for the source code of the application itself is taken from a source code release tarball. And then I also suggest that you build org.kd.kdiamond from the Git master branch, which you do it like this. You go KDE invent kdiamond, gets you to the correct Git repository, https://invent.kd.org/game/kdiamond. And in here, in the top level directory, there's a .flatpak minus manifest.json file. This file name is standardized across the KDE Git repositories. It's always the same /.flatpak-manifest.json. This file, you will be able to see that it's different from the flatpak for the JSON of the flatpak that is for flathub. The one for flathub is a release flatpak, whereas the one from the git master branch, flatpak-manifest.json, is for the git master branch. So you can see that it depends on libkd games, but it doesn't use a stable release source code tarball. Instead, it uses git master branch. Okay. I'm not sure why it doesn't say build system CMake Ninja in here. But it says in here. Okay. Okay, so for production, for flathub, there's all of the sources are of type archive. Whereas for the nightly, there's a KDE flatpak repository for nightly, where this file is being used to create a flatpak, and that flatpak is published on the KDE Nightly flatpak remote. Okay, so the nightly flatpak uses git master branch. The production one for flathub uses release source code tarballs. So this is it. This is how you can take a KDE Git repository that doesn't yet have flatpak and package it for flatpak. You will need to create a flatpak-manifest.json file, which uses git master branch and is being published to the KDE flatpak nightly remote. And once that works correctly, you will be able to create a new directory inside a new Git repository inside flathub for the KDE application. And in there, you will have just one file, the flatpak-manifest.json file copied over, and all of the type gits replaced with type archive, all of the URLs for the Git repository replaced with a release source code tarball, and there should be no branch, there should be a SHA-256. And then there's this automation, which is called Anitya, such that you don't have to keep updating the URL and SHA-256 lines by hand manually whenever there's new source code releases from the KDE project. These are some of the KDE releases. Let's see where the source code tarballs are located. So it's kde.org/info/releases. And then the URLs for the source code tarballs will point to download.kde.org/stable/something.tar.xz. Thank you.